Hello, NDC Copenhagen. So let's get the most important facts out of the way first. We're having a party here tonight on that little stage just behind the curtain, to which you're all invited because you've all got tickets and you're awesome and you've made wonderful decisions. And then we're having another party tomorrow night because one party just wasn't enough. And that's at a bar here in Copenhagen called Mojo, and it is free. And I think Umbraco is paying for all the beer. So hey, Umbraco, thank you. We love you. And you're all invited to come to that as well. And yes, let's talk about machines and learning and machine learning. Now, a few months ago, I bought one of these. This is an Omron X4 Smart Automatic Upper Arm. It's a thing you put on your arm and you push a button and it uses Bluetooth to tell you you're going to die. And I bought this because I don't want to die because I have stuff to do. And the first day I got this thing home and, you set it up and you pair it to your phone and everything. And I put it on and I push the button and it kind of grinds away for a couple of seconds. And then it gave me a reading, 5 out of 10. I was like, oh, that's probably not a good number. But I was quite stressed that day. I had a bit of a busy morning. So I was like, all right, well, I'll tell you what I'm going to do. I'm going to start my health kick. Tonight I'm going to eat a salad and I'm going to get a good solid 8 hours of sleep. And I checked it the next morning when I got up and it was 6 out of 10. And I was like, all right, that's pretty good. And that day I went for a nice long bike ride and I watched a movie and I slept well. And the next day I had 7 out. I was like, this is easy. Like the health kick, I'm smashing it. 8 out of 10, 9 out of 10, 10 out of 10. It took me 5 days to achieve 100% perfect health. The day after that was the 11th of October. And that was when I realized that my smart blood pressure monitor was not anything like as smart as I was projecting onto it. It did have a calendar in it. Now, that's one of the things that I want to talk to you about today is, if any of you caught Richard's opening keynote this morning, one of the things that he talked about at the beginning of that is this human tendency to recognize, to look for intelligence, to look for patterns and intelligent behavior. And he mentioned a thing called pareidolia, which is this human tendency to see faces where there are not actually any faces. And I think about this every time I come here to Copenhagen, because Denmark has the happiest plugs in the world. And every time I walk into a hotel room in Denmark, I'm like, hey, buddy. Oh, it's just a plug. Of course it's just a plug. But one of these days, I'm going to give all the plug sockets names and little hats, and I'm going to have a little party with that. But, we humans, we have this tendency to, if something looks smart, or it looks like it has personality, or it looks like it has any kind of character or intelligence, we tend to go along for the ride. And this is not anything we do consciously. It's because it's tapping into a bunch of circuits that are wired into our brains, because for tens of thousands of years, the people who were good at spotting intelligence and seeing faces quickly, they lived a long time and had a lot of babies. And the people who weren't good at that didn't live a long time and didn't have a lot of babies. And so natural selection has kind of wired this tendency into us. Which means it can be incredibly difficult to make sense of what is happening with a lot of technology at the moment, where we have systems which appear to be incredibly smart, but actually they're just a calendar. And we have systems that appear to be incredibly smart, but actually they're just autocomplete, or they're predicting the next token. And as consumers, as engineers, as people who have to live and work and survive on this planet, we are going through this sort of pretty profound shift about what do we do with all this stuff? Is it important? Are we going to get left behind? What really matters? And what does really matter? Why does technology matter? Why is any of this stuff important? Well, let's start with a bigger question. Why does anything matter? Because Douglas Adams, the author, the Hitchhiker's Guide to the Galaxy creator, he had this very famous quote. He said that the answer to life, the universe, and everything was 42. But then you know what he did? After he'd sold a bunch of million books and he'd made loads and loads of money, and he was like, right, I'm financially secure. I don't need to worry about working today. He did not go home and reflect on the number 42. No, he spent his money on computers and guitars and synthesizers and going on holiday and throwing parties and, by all accounts, having an absolute blast with it all. And then he wrote another book. Well, no, it's not quite that simple. Then he would sign a contract in which he agreed to write another book. And then, by all accounts, he would do absolutely anything possible to get out of actually writing it. Douglas hated writing. He loved being a writer. He loved being able to point to books he had written and say, I did that. But the physical act of sitting down in front of a word processor and putting words one in front of the other, he would do almost anything to get out of doing it because he hated that part. And it drove his publishers nuts. He had another famous quote, I love deadlines. I love the whooshing noise they make as they go by. And on a couple of occasions, his publishers, Pan Macmillan, would send somebody to lock him in a hotel. And he was only allowed out for meals and cigarettes, and other than that, he was not allowed to leave the hotel until he had finished writing the next book, because they had a contract to publish it and sell it and get it into bookstores. And, there's no way that was going to happen. Now, there's an important contrast here, because the experiences that drive us to do things, the meaningful experiences that we have in life, I think they fall into two categories. There are the things that it is nice to do. It is nice to sit around in a bar and drink beer and laugh with your friends. It is nice to eat pizza and watch movies. It's nice to sit on a beach and watch the sunset. There are the things it is nice to have done, but which totally sucked while you were doing them. Two categories of fun. There are the ones that you're like, yeah, this is awesome, and there are the ones that are like, this sucks, but one day I'm going to be really, really glad that I did this. And there are short circuits, which we are going to come back and we're going to talk about short circuits a little later, because they put a different spin on one of the things we're going to be talking about. But has any of you folks ever run the marathon? We got any? Yeah. How was it? Was it fun? Did you enjoy it? Like you're going 30 kilometers and one of your toenails is falling off and you're sweaty and you're like, no, it's not fun. I know lots of people who have run the marathon. None of them enjoyed doing it. The day that they ran the marathon was horrible, but all of them are like, I'm really glad I did it. And most of them are like, and I'm never doing it again. But it's really important. They set this goal, they focus, they work towards it. The day that you folks ran the marathon, I didn't run the marathon. I probably slept late and ate leftover pizza in front of a bad movie about spaceships. And I probably had more fun that day than you did. But to you, that will always be the day that you ran the marathon. And to me, it was just like some Sunday, I don't even remember where I was or what I was doing. And this is important, this idea of the contrast between the things that are fun because they're fun when you're doing them, and the things that are fun because you can say that you did them. You go and ask any of the folks who are speaking here at NDC Copenhagen, ask them before their talk if they're having a good time. No. I hate myself. Why did I do this? I was up all night making slides. It's going to be horrible. I don't want to do it. I don't know why I even volunteered. I hate conference. Ask them 5 minutes after their talk. They'll be like, it's amazing. I love it. It's the best thing ever. I'm so happy. I'm going to do all the conferences. And then they will all go home and look on Session Eyes and find all the conferences and apply for all the other ones because they want to put themselves through the grinder again. And I include myself in that. And that, I think, is, it's a big part of it, is being able to choose the things that you want to do. Choose the experiences that are going to make life meaningful. And sometimes you want to be able to get up and say, you know what, I'm taking the day off. That's a lovely thing to do sometimes. And sometimes you want to be able to get up and say, you know what, I'm going to run the marathon. And your partner or your family or your colleagues will be like, oh, brilliant. Yeah, honey, you can run the marathon. First go to work, and then you got to pay your bills and your taxes. Then you got to buy groceries. You've got to make dinner and feed the family and do the laundry. And when you've done all that, you get out there and start training for the marathon. Big guy, we got your back. And you're like, actually, when you put it like that, and this is why technology is important, is because it takes all of these things out of the way and it gives us more choice, more freedom about what we do with the time that we have left. About 1,500 years ago, just finding enough food to not die occupied something like 80% of the waking hours of the human beings alive on this planet. If you had a family of 5 people, 4 of them would spend all day, every day, farming or hunting or gathering just to ensure that you had enough food to raise kids or to look after elderly relatives. Today, we have reduced that number. Industrialized farming means that now one person using technology, modern tech, one farmer can feed 150 people, which means the other 149 people can become airline pilots, or they can dance the ballet, or they can invent JavaScript frameworks. They can do other things. We have labor-saving devices. Used to be, when I was a kid, laundry day took one person in the house a whole week. Then we got a washer, and then we got a dryer. And now most of us don't think that much about the time taken to do laundry. We got to do it. You got to load the machine. Do you remember that cartoon show, The Jetsons? Judy Jetson's got a thing, empties a laundry hamper into it, and the clothes just come out folded. Why don't we have that? Like, come on, why are we doing AI when we could be building that? And, there is a nice idea of it would be great to live in some kind of utopian technological society where nobody has to do laundry and nobody has to wake up and run the marathon unless you want to. And we are completely free. All of our needs are met. We have shelter, we have housing, we have food, we have healthcare, and all these other things. And we can just choose, what do you want to do? You want to run marathons? You want to write books? You want to write music? You want to sit around and eat pizza and watch movies? That's cool. And that's why I think tech is important, is because it, used properly and deployed effectively, gives us more control over how we are going to spend our time. And it is incredible how quickly we start to take it for granted, because you have a black slab of glass in your pocket, and you can be sat at home on your couch, and you can pull the slab of glass out, and you can go beep, 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 beep on it, and 20 minutes later, boom, pizza, actual nice edible pizza. It turns up, it arrives at your house. And the first time I did this, I was like, this is amazing. Like, I managed to order pizza without having to make a phone call, because no one wants to make phone calls. And the second time you do it, it's like, oh, I'm going to do that pizza app thing. And the third time and after a while, it just becomes mundane, And the only time you remember it is when it goes wrong, when the pizza goes to the wrong house, or when you get the pizza and it's the wrong order, or if they forgot the pepperoni. And the reason why we remember that is that we take things for granted when they are deterministic. When the outcome, we put in a certain set of inputs, and the outputs to those are going to be predictable. Now, determinism is a really big idea underlying concepts of what it means to have a fair society. We have this notion, two people walk into the same restaurant, they order the same food, they should pay the same price. Two people do the same work in the same company, in the same industry, they should be able to earn the same salary. It's deterministic. Two people go to court, they stand trial for a crime. Same evidence, same accusations, same circumstances, they should expect to face the same amount of justice. When this doesn't work, that is when we get prejudice. That's when we get unfairness. That's when we get all the things that make people really angry. Now, the real world has got a long way to go before we actually get there. But inside the computer, we can absolutely be deterministic. Does 1 equal 1? Yes, it does. Right now and today and for all time, 1 equals 1. We can bet the bank on that. Does 0 equal 0? Yes, it does. Have you ever worked on a project that had a flaky test? Just a test that, you run the thing and it fails. And you run the thing and it fails, and you say to someone, hey, you've got a test failing. And they're like, just run it again. Oh, yeah, that test doesn't work on Tuesdays. We'll deploy it in the morning. And it becomes part of the fabric. It becomes part of the folklore of that project. Is you've just got a couple of tests that sometimes they don't work quite right. Run it again. Eventually, you'll get a green light. And when it passes once, you're like, well, it passed once. So obviously, the code is fine because it passed one time. Let's just go and deploy that to production. And then one day you decide, you know what? I am sick of it. I am not here to gamble. I am going to take the metaphorical fruit machine apart, and I am going to figure out what's going on. And you attach a debugger, and you run the stack trace, and you figure out, oh, well, obviously that's going to happen, because in Nepal, they have a 45-minute time zone offset, and we have a 15-minute sliding cache expiration window. And so obviously, if a customer in Nepal sends a request at the exact moment that the daylight saving time is going to change, and you determine that there is a reason for this, and it's not randomness. It is a set of external circumstances which are just way more complicated than you ever gave them credit for. Now, we have got very, very good at engineering the randomness out of software when it is time to test it. We're like, okay, we're going to build a calculator. We're going to build the best calculator ever. So to be able to test our calculator, we need to isolate environment variables. We need to isolate the clock that the thing is running on. We need to isolate the network. We need to the host and the configuration. All of the ambient context and the things which are different between my machine and your machine and their machine and the cloud, we take all of those out of the loop and we lock them down, we control them, and then we can calculate stuff really, really well. Now, the two things about technology that it's easy to lose sight of. One, code is lovely, calculator is lovely. This is all isolated. We have cut our code off from the real world to be able to test it and verify that it works. Thing is, code that's cut off from the real world isn't actually of any use to anybody. The code, the tech, which is interesting, is the code that makes things happen in the real world. It's the code that delivers pizza to your door and makes the movie come up on your TV so you can sit and relax with your family. It's the code that delivers the yarn to your house because you don't have enough yarn and you need more yarn for your next project. Or it's just the code that says, I'm hungry, bring me pizza now. And the difficulty here is real life is non-deterministic. There are bits of it that we can forecast. There is a lovely quote from one of the books about chaos theory that said, we can predict the tide, but we can't predict the waves. We know when the tide is going to go up and down, but we can't tell the surfers, hey, you need to be out there at exactly 7:15 p.m. It's going to be a really good wave. That element of it is random. We know roughly how many people are going to end up in hospital in Copenhagen tonight. We don't know who they're going to be. You can't point to one person and go, yeah, probably better stay at home tonight. It's not looking good for you. But we can forecast with a certain degree of confidence what's going to happen with traffic plans, what's going to happen with how many people are going to buy tickets to a certain event, that kind of thing. Except when we can't. We get what are called black swan events. Nicholas Nassim Taleb, the economist, is like, sometimes things happen which are so unpredictable. When Taylor Swift did the Eras tour a couple of years ago, the entire international concert industry was like, we don't know. We have no idea what's going to happen. Qantas were flying, was it 380s or 7? They were flying massive aircraft between Melbourne and Sydney because there were so many Swifties wanting to go to the concert and get back. They needed to put on bigger aircraft. That doesn't happen. One person on a stage singing songs doesn't mean you need to upgrade your flag carrier's national fleet, but it did because it was so far outside the prediction, the horizon of what they were capable of predicting. Now, technology tries really hard to put some layer of determinism over the top of all of this. The best example of this is the internet. Now, the internet gives the impression, unless you're on conference Wi-Fi, of being solid and fast and stable and reliable, and it's how all of this stuff works. It's how we stream movies, it's how we do FaceTime calls, it's how we do emails and everything. Underneath the internet, TCP/IP, the transmission control protocol, guarantees that if I send you a packet, you're going to get it. TCP is built on top of IP. IP looks like that. IP don't guarantee shit. IP says, put a packet on the internet, thank you, and you're like, what happened to it? And IP goes, we don't know. It's over there. It's in the cloud. Or it might be in the water. We don't know where it went. And so TCP, they have engineered a way of building reliable, guaranteed in-order delivery on top of an unreliable data layer. If the piece of cable that is taking your FaceTime call from here to Boston gets hit by the anchor of a shipping trawler at the exact moment you're on the call, it'll just route it via another cable without you realizing anything much has happened. So one technology tries to put this deterministic layer over the randomness of real life. We try to take things like, there's a million ways getting pizza to your house can go wrong. Let's see if we can factor all of them out so that we can deliver pizza reliably. The other thing, which I think is interesting about the relationship between tech and reality, if any of you went to computer school and you learned about transactions in databases, you will have had this lecture where the lecturer says, all right, so you need to imagine we're building a database for a bank, and the worst thing that can happen is that we take the money out of this bank account, but then it doesn't go into that bank account. And so we have transactions, and we are going to update the account balance from account to account, take the money out of here, put it into here, and then we commit the transaction atomically so it will either fail or succeed, but the money never goes missing. Because if the money goes missing, you go to computer jail for the rest of your life. And then you get out in the real world and you talk to people who work in banks, and they're like, oh yeah, we have an entire department for people where the money went missing. Left one account, didn't show up in the other one, we don't know where it went. Reality doesn't work like SQL transactions work. Reality is chaotic. All kinds of things go wrong. Reality is far more resilient than anybody gives us credit for. But we do, this is what we are trying to do. This is what tech has been trying to do, is to take probabilistic reality and put deterministic abstractions over the top of it so we can build systems that worked when we ship them, and they still work today, and they're still going to work next week and next month. And then within the last few months, something has come along which has profoundly changed the relationship between software and engineering, something which has, it's changed the playing field. It might be the most profound thing to affect the way that we develop software that has happened in my lifetime, because in May this year, they released Node.js 26. Nah, not talking about Node 26. I'm talking about AI. I'm talking about artificial intelligence and Gemini and Kiro and Grok and Claude and ChatGPT and OpenAI. Now, when I say AI, what I am specifically referring to is any product developed in the last 3 years which has this button in it somewhere. That's it. That's the definition. I'm also talking about using AI to write computer code. If you want to talk to me about using AI to make music or make movies, you will have to come and find me in a bar where the code of conduct does not restrict what I'm allowed to say. because I have opinions, and they are best shared over strong drink. Now, I've been writing code since I was 8 years old. I have written code in all the languages, Logo and Basic and Scheme and C and C++ and HTML and JavaScript and web standards and SQL and Ruby and JavaScript, the good parts. I have never seen such a profound disconnect between the hype and the reality of any piece of technology, any innovation. Let's imagine for a second, let's imagine that the scientists, the smart people with all the venture capital, they're going to invent a new kind of snack. They're going to invent a double fermented smash kombucha cheeseburger, the Booch Burger. And you try the Booch Burger and you're like, you know what? That's good. Like, that's really good. Like, that is the best burger I've ever eaten in my life. This is a miracle of food science. The Booch Burger is high protein, low sodium, low fat, very economic. It doesn't involve any animal ingredients. It's completely sustainable. You're like, you know what? This is good. I quite fancy that. And then a couple of months later, you're in the grocery store and you notice that literally everything they sell has now got Booch Burger in it. They got Booch Burger oatmeal and Booch Burger cheese and Booch Burger pickles and Booch Burger milk and Booch Burger dish soap. And you're like, it's a good burger, but I'm not sure we need it in all of these things. And then the CEO of McDonald's goes on the news, and there's an announcement. McDonald's is investing $1 billion in Booch Burgers, because clearly this is the future of the fast food industry. And you dig a little deeper, and it turns out they haven't actually, we're not talking about $1 billion in actual money here. What we're talking about is they've done some deal which is $1 billion worth of discounted burger franchise outlets. And so on paper, they just got $1 billion of investment, and somebody else just got $1 billion worth of revenue. In practice, neither of them actually has any money. The only people in all this who are actually making any money are Engridlia, because Engridlia, the company that make the griddles. And you can't make Booch Burgers unless you got a whole lot of griddles. So Engridlia out there, their CEO, does an interview with CNN, and he says that in another 6 months, Booch Burgers are going to be more important than drinking water. And everyone's like, that doesn't quite add up. Now, there's a problem. It's a little tiny problem. Most of the time, the Booch Burger is an amazing and excellent and tasty snack. Sometimes it tastes like cigarettes. Sometimes it tastes like wet dog. Sometimes it comes out radioactive and you die. And one time, a Booch Burger accidentally exploded, and it took out half a city block. Fortunately, everyone was at the Taylor Swift concert, and so nobody was injured. And so word of all these catastrophic product defects gets back to Booch Burger International, and they're like, oh, should probably do something about that. And they say to the scientists, do you think you could make them not explode? And the scientists are like, not really. Byproduct of the kombucha fermentation process. There's not a whole lot we can do about it. Like, I know what we'll do. We'll put a little warning on the label. Booch Burger may contain surprises. Please enjoy with care. Now, how does any of this lot add up? You know, the most remarkable thing about the Booch Burger is, for a long time there, they were giving them away for free. And you could walk into anywhere and just have as many Booch Burgers as you want. And you're like, well, if they're giving the burgers away for free, how are they ever going to get their $1 trillion back? I know you're not supposed to ask those kinds of questions about the glorious future. The economics of the whole thing just do not add up. We are at a point now, I'd love to talk about burgers for the rest of the day, but we're not. We're talking about AI. We're talking about language models. We're talking about data centers. We are talking about the obscene amounts of imaginary money that have been sloshing backwards and forwards between companies who are staking the future on products that might get good soon, companies that are staking it on products that already exist, but they are so heavily subsidized that no one really knows what it's going to cost when we have to start using these things for real. The only company at the moment who are literally sitting on, they're making bank on this, they are sitting on massive piles of cash, is NVIDIA. Because NVIDIA sell the hardware that you have to use to pretend you're going to make the imaginary money. So what are the rest of us going to do about it in the meantime? You know, how do you as an engineer make sense of the fact we have these amazing things, and sometimes they're fantastic, and sometimes they're not fantastic, and we don't really know how much they're going to cost, and the entire world economy is basically a kind of bubble propped up on imaginary AI money at the moment. And, you know, basically, well, one, we might as well enjoy them as long as they're free, but two, when they stop being free, what are we going to do about it? What is the outcome of all this? What does the end game look like? The questions that we really got to ask about this, the thing that I think is it kind of boils down to for anybody working in tech is, AI is not going away. It is here. What are we going to do about it? What is each of us individually going to do about it? And how do we know if we're right? How do we know if we made the wrong call? And if that happens, what can we do about that? Now, one of the challenges here, language models have a tendency to fabricate, something that is known as hallucinations in the parlance of the industry. Now, hallucination, I don't like that word. A hallucination is something that a sentient conscious organism does when it experiences stimuli that are not out there in real life. It's when you see things that aren't there. It's when you hear things that aren't there. A language model can't see anything. A language model can't hear anything. A language model just predicts the next thing in a stream based on a probability of some tokens in a massive vector database. But it is incredibly difficult as a human being to get over the fact that it looks like most of the time it's giving you the right answers. And so when it doesn't, the tendency is to go, oh, well, it must have made a mistake, because we project this. We project consciousness onto machines which are not actually conscious. Now, you come across this expression, vibe coding. This popped up last year, and then it went away, and then it came back, and then it went away. And like a lot of words in tech, a lot of people talk about vibe coding. I don't think we have a single accepted definition. There is, I think, a congealing consensus that vibe coding is basically you give the AI the prompt and then the code goes to production and that's just it. And then you give it another prompt and round and round and round you go. And yeah, it can do this. You can go on, and I'm sure you've seen demos like this before. I've sped this one up 50 times. It's not actually this quick, but you can go in and go, hey, build me a purple login system in .NET 8. And it goes, yeah, I can do that. And it cranks away for a couple of minutes. And before very long, it's like, yeah, can I run it? And we're like, yeah, you can run it. Go on. .NET, what's the worst that can happen? And boom, there it is. We've got a purple pass login system with password reset and everything. And it's even fabricated an imaginary company called Purple Pass to assign the copyright to, because you can't have a login system without copyright, can you? I don't know. But also, it's a login system. Like, whoa, big deal. We had those already. Now, I've been doing a bunch of work over the last years building workshops and training manuals for courses that I run. And one of the things that crops up time and time again is there's a lot of code in the handbooks for these. And we have tools to make code look good, and we have tools to lint them and format them and indent them. And once you start writing documentation, a lot of those tools go away because you don't have access to them in something which is optimized for writing prose or writing text. And I wanted to be able to pull in little snippets of .NET and JavaScript code into a web page. I run most of them on Jekyll, so I write code in Markdown. That compiles down to HTML. I put that up on the web, and I was like, I wonder if I could build a custom plugin. Now, Jekyll is built in Ruby. I have worked with Ruby. It's not my favorite language. I'm not terribly familiar with its idioms and things, but I thought, that's all right. We've got agentic AI now. I can get that to do it. And so I fired up Copilot, and I said, build me a custom Jekyll plugin that'll let me specify line numbers that I want to highlight when I include. And I gave it, this is the sample code I want to be able to write. And it did it. And I was like, oh, wow, that's amazing. It actually works perfectly, first time out of the box. But then I got carried away. And I was like, oh, I wonder if it can do this. Can I give it the name of a region? Can I give it a CSS selection path and have it find the matching element in a bunch of HTML and pull out just that element and take the indentation off and format it and everything? And what happened is, over the course of a couple of days, let's imagine that I had written this Jekyll plugin by hand starting from 0. So this is a graph of time against features, feature maturity. How capable is this piece of code? If I had just sat down and written it, it kind of would have done this. And, there's a little bumps along the way, but it gets better and it gets bigger and it gets more capable as we go along. And what I discovered doing this using Copilot is, boom. But then I would ask it to make a change, and sometimes it would shoot itself in the foot. So at one point, it managed to get it so bad that it actually broke the entire build and then pushed everything to GitHub. And I told it to do GitHub snapshots before doing anything so I could always revert. And somehow that instruction got translated to, if I make a really bad mistake, I need to put it on the internet so the rest of the world can see it forever. But more importantly, if you were to plot my level of understanding of what that piece of code did, my ability to reason about it, fix problems with it, and be confident of its capabilities, if I'd written it by hand, understanding kind of does this. And it ends up at a point where I know what the code does, and the code does what I think it does. Using agentic tools, to me, the level of understanding with pure vibe coding, you don't know anything. You know that it kind of worked mostly one time. Now, this gets us down to what I think is a really, really important factor in the way all this stuff works is I got to a point where I would be punching instructions into Copilot and waiting to see, and when it got them right, I would be like, yes, winner, winner, chicken dinner. And when it got them wrong, I would be like, come on, I thought this thing was going to be fixed. I want to get done. I want to go out for the rest of the day. It should be magic. The magic should be working. And this got me thinking about a guy called Skinner, B.F. Skinner, who in 1948, he was a psychologist at Harvard University. And in 1948, he published a series of very influential papers about something called operant conditioning. And operant conditioning is teaching, in his case, he was using pigeons and he was using rats, teaching them to behave in certain ways by giving them a treat. Can you incentivize behavior using reward and reinforcement? Now, one of Skinner's most famous experiments is he took a bunch of rats and he put a rat in a cage with a button. And when the rat pushed the button, in group A, every time the rat pushed the button, nothing happened. In group B, every time the rat pushed the button, it got a food pellet. In group C, sometimes the rat would get a food. Not every time, but sometimes. Now, the rats in group A, they were real happy. They're just like, push the button. Oh, I guess that's just a button. I'm going to go over here. I'm going to be a rat. The rats in group B, they're like, yeah, I can get food whenever I want. They very quickly figured out they don't need to worry about it, and they could just get on with being very fat rats. The rats in the third group, the ones who, when they pushed the button, they might get a food pellet or they might not, they lost it. They forgot how to be rats. They forgot to be interested in other rats. They just spent the whole time mashing the button and mashing the button and mashing the button. They forgot to sleep. They weren't grooming themselves properly. They exhibited serious signs of psychological decline because they had this thing that they might win. This thing that every time they checked it, there was a little likelihood, it wasn't a guarantee, but there was a little chance that they might win something. This is called variable ratio reinforcement. Now, be honest, how many of you have checked your phone messages or your social notifications since I started talking? Yeah, because you might have a food pellet, right? There might be a little tasty snack there. Someone might have liked one of your posts on Instagram, or you might have a message from somebody, or someone might have liked one of your comments on the group chat. This is an incredibly powerful behavior. This is why social media invented infinite scrolling. This is why social media has become so pervasive, is because it taps into the same mechanism. You might get a food pellet. You better check, because you might have one. And so you check and you check. It's how gambling works. Now, this is same idea. You play fruit machines, you might win something. If you won every time, well, that's a cash machine. It's boring. If you never won, well, why would anybody do that? It is the possibility. Now, I was reminded of this a couple of weeks ago. I was on my way. I was going to Tekorama in Belgium. And I have a lie which I tell myself with regularity, and I will never learn the truth. And that lie is that I can work on the train. Because when you get on an aeroplane, like a normal aeroplane, not like a posh aeroplane, you put your phone in airplane mode, and you don't have any internet, and you're just fine. You sit in the sky, and you eat your snacks, and you watch your movies on Netflix, and you're fine. You're just a normal, healthy, well-adjusted little rat. And when I'm at home, I have gigabit fiber running into my house, so I'm the fat rat with all the snacks, and I'm happy, and the internet just works, and I don't think about it. But when I get on a train, the train has Wi-Fi, right? Nah. The train says it has Wi-Fi. The train does not, in fact, have Wi-Fi. The train has just enough Wi-Fi that you know you've got a message, but you can't see who it's from or what it's about. And so you spend the next 15 minutes frantically disconnect and reconnect and put it in airline mode and turn it back into airline mode. It is this inconsistency, this undetermined non-determinism, the fact that it might work but it won't work, is really, really unhealthy. And I'm hearing from more and more people now who are there working with AI loops, and they're doing this to do more and more of their kind of development work. And they're getting to the end of the day, and they're like, I don't ever remember being this tired from sitting and writing code. I'm absolutely burned out and exhausted at the end of every single day. And I'm like, well, yeah, you're basically, you're gambling. On some level, you are using non-deterministic machines, and a lot of people are doing great things about trying to make them more deterministic and figuring out ways to steer the behavior of the models and build what they call guardrails, which stops it doing some of the most egregious things. But fundamentally, we are still trying to use a non-deterministic process to produce working software, and that is always going to be a sort of uncomfortable process. And so you get to a point where it's like, oh, bang, 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 we got a 5,000-line pull request. Claude wrote it. What happens to it? Who wants to review 5,000 lines of code? Any of you folks maintain open source projects out there? and you've started getting contributions from people who are like, hey, I asked Claude to add this feature to your thing, and it wrote all this, and here's my PR, can you merge it? And a lot of organizations, and particularly open source ones, are now going, we are no longer accepting contributor requests. You need to establish your credibility with our community before you will even think about looking at your code. Some others are like, yeah, you know what? Fine, just ship it. It looks good. How bad can it be? We don't know yet how bad it can be because we haven't had the headlines. But bad is probably coming, and when it does come, it's going to be interesting to see the fallout and how the chain of accountability plays out, especially when we are increasingly seeing software that has been written using AIs, reviewed using AIs, deployed using AIs, and supported using AIs. Was it Meta this week had a thing where you could ask their chatbot to give you someone else's account, and it would, because you knew the email address, so obviously it must be yours, and you can't get through to a person. It's just, these tools doing it. Now, the important thing here to me is the distinction between developing and delivering software. The key word is delivery. What are you pushing out into the world? Who is it aimed at? What are they going to do with it? There's an analogy I've heard a lot of people talk about, which is they said, well, for the last however many years, we've been in the craft era where code had to be written by hand. Just like furniture used to be created by artisan carpenters, and every piece was unique and hand-constructed, and you could get a very, very good job making wooden chairs for the rest of your life. And then we invented IKEA, and now nobody makes wooden chairs because you just go to IKEA. This is the wrong analogy, because the reason why IKEA succeeds is that they solved the problem of chair delivery. Software's not chairs. We solved software delivery years ago. You download it. If you are going to create a single prototype that you can replicate for fractions of a cent and sell as many copies as you want or give them away for free, why would you start with an IKEA chair where you could start with a 16th century handcrafted chair and then just replicate that one for fractions of a cent? So this is not about the cost of delivery. Once the software's done, we know how to get it to all the potential users' customers. That's been solved for years. What we're talking about is, how does it get done in the first place? How does it get to that point? And for a while, if you wanted to solve a problem with a computer, you had two choices. One is you'd be like, has someone already solved this problem? I need to do something with JPEG compression. Oh, look, I can install a package. Problem is already solved. I need to find a certain string in a text file. Okay, cool, grep already exists. I need to write my final year report for my university. Hey, Microsoft has a thing that does reports. I can use that. And if you couldn't find anything to do it, you'd sit down, you'd be like, I could solve the problem, the long way around, or I could write a program to solve the problem for me, because that would be way more fun than actually solving it, right? And this, to me, highlights the distinction between programs and products. I've got hundreds of programs. They are useful. I use them. They do cool things. Some of them do process source code. Some of them are build pipeline tools. Some of them do interesting things with karaoke videos. I would never dream of trying to sell any of them because they're not products. They work on my, some of them only work on my machine because they've got C/users/Dylan hard-coded into the path name, because there's no reason for me to do anything else because all my computers have got that on them, except when I run them on Mac OS. Understanding the output, understanding the impact and where the code is going to go can be incredibly important. Liam Wesley has a lovely story. Liam was working at Sky TV in 1997 when they had a UK general election. And he and his team were doing the broadcast graphics for the all-night live newscast about who was winning the election. And Liam says, they went into it and they're like, oh, we need an interface, we need a database to manage the inputs and outputs. And he's like, no, we don't. This is going to run once for one night. It's going to be on live TV. There won't be another election for 5 years, and they probably won't be using Visual Basic 4 in 5 years. So it's only ever going to get used once. The important thing here is not the software. The important thing is the television. And so what they did is they wrote a little program that did graphics in VB4, and they put a breakpoint on the line where they had all the results of all the elections. And when the phone rang, they would answer the phone, change one of the numbers in the debugger, push F5, and it would run one more cycle, update the graphic, and then sit on the breakpoint until the phone rang again. And it's live TV. That was the perfect solution for this problem. As software engineering, it's absolutely horrible. But as a way of getting live graphics onto a TV broadcast, live TV is chaotic. They know that. They have producers who know that if the Visual Basic crashes, they've got to cut to, here's our reporter in the studio. They can do that. It is the right solution for that kind of problem. And the world is full of examples of chaotic engineering yielding very robust, resilient products. When they made the original Star Wars, 1977, a lot of the models and the props that Industrial Light and Magic used, they didn't survive the filming process because they weren't building models to sell. They were making a movie. As soon as they got the shot, that's it. It's done. When Queen was recording Bohemian Rhapsody at Abbey Road Studios, they wore out the tape. Like the original multi-track tape for Bohemian Rhapsody, they overdubbed so many times it ended up transparent, and they had to bounce the whole thing onto another tape. The means of producing it did not survive the process, but the product is resilient. And we are surrounded by examples of products that are part of everyday life that were produced by non-deterministic, chaotic processes. We know how to do this. We know how to embrace non-determinism as part of a development process. The problem is the thing that comes out the other end, that's got to be reliable. That's got to be trustworthy. It's got to be safe. And this is where the expression, we're starting to talk more and more about the human in the loop. This is the AI can generate the code. The AI can build the pipeline. It can do the analysis. It can help you plan stuff. They can do some phenomenal things. But at a certain point, the human being needs to be like, yes, this is going to be my work. This is going out there. And AI can't be legally liable for anything. The one thing has come up, the AI doesn't want a pay rise. The AI doesn't want to share the profit. So at some point, there's a human in the loop because the human's going to be the person who wants the money. And if that person is the person who thinks they're entitled to the money and there's no other humans, they are the human in the loop when the software goes wrong. I see any entrepreneurs going, no, that's not how it works. Claude is liable. Microsoft said so. It's fine. Now, there is an angle to this that I think is really exciting. I learned to build web applications using something called the Publish to Web Wizard in Access 97. Which meant I could build a database and turn it into a website, and then I could take the website apart and see how it worked, and I could change things. And if it broke, I could make another one and take that apart and see how that worked. And some people, they learn very well from reading. Some people learn well from video. I learn from taking things to bits and putting them back together. And it is really nice for me and for a whole generation of aspiring developers out there now. We have a tool that's like, hey, can you build me a video player in Python? And it does. And you're not going to go and sell that, at least I hope you're not, but it does mean now you have a working video player in Python that you can take it apart and see how it works and find the bits that are wrong with it and fix them and tweak them and learn from the experience and develop your own capability as an engineer. And this always gets us around to the question which has been the headlines for years now, will AI replace software engineers? Now, at this point, we got to scan for a little bias because I do not have a completely impartial, objective answer to this question. One, I quite like being a software engineer. I do not want to be replaced with AI. Two, it's a lot of fun and I can get paid for it, and it would really suck if that stopped. Three, I like the idea of human beings building the software that I am going to be forced to use for the rest of my life. But I do not think AI is going to replace software engineering anytime soon. It is going to change it. It is going to fundamentally alter the nature of a lot of things about how we build code and how we do it. But software which has been completely coded, just put the prompt in, get the results out, ship them, even the people who love this stuff, people who are absolutely immersed in it, still cannot reliably produce stuff. Do you remember Maltbook earlier this year? Maltbook, the social network for AI agents. This made headlines for about a week until we found something else to talk about. And the creator of Maltbook famously said, I didn't write one line of code, I just had a vision, and AI made it a reality. And then 48 hours later, exposed database, let anyone take control. The thing was wide open. There were Firebase keys in the wild. There was no security. There was no authentication. Now, there's two other things which I just keep coming back to in this whole kind of bigger question around how much AI can and how much it is revolutionizing the craft of software. And one of them is the people who are going all in on it, they are still selling AI. And let's imagine that you had designed a machine that could build houses. You had designed a machine that you could rock up to a construction site, you push a button, and instead of taking 6 weeks for the contractors to put a house up, it could happen in 6 hours. If you had that machine, would you be going around trying to get people to invest in your machine? Or would you just be building a shitload of houses and selling them? Because if the machine existed and you wanted to make a lot of money, you wouldn't do it by selling the machine, you'd do it by selling the houses, because that's the thing. There's the market. There's the demand for that. There's a lot of software out there which people don't like, and there is a market for a better version. Give us a version of Adobe Photoshop that looks exactly the same, but it isn't $50 a month and it's not made by Adobe. We'd love that. Give us a version of Microsoft Office that doesn't keep putting Copilot updates in places where you didn't ask for them. The appetite for these products is there. The market is there, but AI is not seeming to be able to deliver them. And the other one, and this is kind of bleak, like I am not as to whether I wanted to put this in, but I have lived through 2 revolutions in information technology. I'm not counting cloud because most normal people didn't notice cloud. Cloud is a big deal if you work in our industry. Rest of the world were just like, oh, website's a website, I don't know. But I was there for the first dot-com boom, the advent of the World Wide Web, the Netscape, IPO, all that kind of stuff. When that happened, that was the 90s. The Berlin Wall had come down. The Soviet Union had disintegrated. Nelson Mandela was president of South Africa. Everything was great. And they still wrote grunge music about it because they didn't know how much worse it was going to get. The 90s, when the web was in its ascendancy, was just this wonderful, exciting, upbeat time, and it looked like, freedom and democracy. The Cold War is over. It was all going really well, and Netscape and Internet Explorer, and anyone can make websites, and it was just a really kind of cool time to be involved with it. And then about 2008, like smartphones and social media and Web 2.0 and Twitter being the actual global town hall where you could complain to an airline and they would apologize and come back and fix stuff. And smartphone, no one ever had to be told to use a smartphone because you saw someone do the pinch zoom on the maps and you're like, I want that. That is just, I need that. I will be unhappy now until I have one of those. ChatGPT kind of hit the mainstream where real people were using it in October 2023? And you look at the state of the world since then, if AI is good, why is everything horrible? Like, if this is this amazing tool which is going to revolutionize the technology that we use to live and work and play and interact, why is everything more expensive? Why are there wars everywhere? Why is democracy backsliding? Did they just pick a really bad time to try and tell the world about this really amazing thing? Or is there something about the nature of the relationship between human beings and truth that is looking very, very precarious right now, and AI really is not helping? I don't know. But I'm not going to stand up here and say, hey, AI is amazing and the world's an amazing place, when it's clearly, you go outside, look around, and it's really not. And I hope it will be again soon. But right now, trying to persuade anybody that Copilot is going to fix their problems is like, we all have problems that Copilot's not going to be able to fix. Now, I want to round out by maybe addressing this at the folks who are early in their career, folks who are looking at all this stuff and going, well, what do I learn? What do I do? What's going to happen? Should I learn programming? Should I become a prompt engineer? Do we still have prompt engineers? We did for like a couple of days, but is that a thing anymore? Should I give it all up and go and become a plumber? Should I just start stockpiling ammunition in my house in anticipation of the inevitable end of days? I think the most important thing to understand is, let's take a human being who's happy. Let's take somebody who has just had a meaningful experience that ideally is something they're prepared to pay for, whether that's payment in cash or payment in kind, something that has value to them and therefore can be part of some kind of economic transaction. Why are they happy? Well, fundamentally, for one of 4 reasons. They're happy because of dopamine, serotonin, oxytocin, and endorphins, because that's all it is inside your brain, there are these 4 transmitters, and this is how happiness happens. And so a lot of what we do is understanding the mechanisms that will trigger those things. Dopamine is it's the anticipation chemical. It's the thing that makes you stay up late having one more go on Tetris. It's the reason you're still coding at 3 o'clock in the morning when you should be in bed, because every time you fix another bug or something, you get a little rush of dopamine. Serotonin is well-being and contentment. That's the thing that makes you feel good when you're with your friends, with your family, when you're not worried about paying rent and paying bills and stuff. Oxytocin is the love neurotransmitter. It's the thing that makes you feel loved up. And I don't know what endorphins are because I don't think I get them, but some people look happy at the gym, and I think endorphins is what's happening to those people. We can't do that directly, because if you could just say, hey, take this, what is it? It's dopamine in a pill. You'd be like, yeah, okay, brilliant, fine, it's amazing. Can I have some of the serotonin? I'm a little edgy. Just balance that out and ride it on a wave of artificially induced chemical. Nah, it's not going to work. But think about someone who is happy, somebody who is currently experiencing one of these neurochemical conditions. Maybe they're happy because they just ate a delicious meal. Well, if you're a chef, hey, cool, you made the good thing. Maybe you're not the chef. Maybe you're the delivery rider who took the meal to that person. And, it's a little bit more disconnected. Most people don't thank the delivery rider. Well, they do pay a tip. Or maybe you're the person who built the navigation software that is being used to do that, in which case you can be like, I made that. Like, there was this chain that led to a happy person with a delicious bento box, and I was part of making that experience happen. Or maybe someone is there seeing their friends, and they took a train journey to get there, and you're not one of the friends in question, and you didn't drive the train, but you built the ticketing app. that they use to get there. And so you can draw a connection between the work that you do and somebody having a valuable experience. They're listening to a new album by their favorite band, and it's really good. And you're like, well, they're listening on a streaming platform, and the streaming platform uses this audio compression system that we worked on, that we built. And so in some little way, we made that happen. But the problem is that there are people for whom the happiness is the result of a short circuit. Some of them gambling. I worked with a guy years ago who left to go and build gambling websites. And I was chatting to him. I was like, what do you do about marketing and retention? He's like, we don't have to. Like, we know exactly why people keep coming back. They're addicted to our product. They come back and they play video poker. And the worst thing that could happen to us is the government turning around and telling us we're not allowed to do that anymore. They had absolutely no need for things like Google Analytics or any of that kind of stuff, because that's all about trying to map this indirect journey. And they're like, no, it's a direct one-to-one direct hit, Drugs is the same thing, but so are share prices. There's a lot of folks out there who their compulsion at watching the value of their stock go up is, for some reason, we've decided this is successful. If you are hooked on drugs, if you're hooked on gambling, that's a problem. That's a social problem. If you are hooked on capitalism, you are successful, and we applaud you and we salute your success. And there's a lot of folks out there who the only reason their job exists is that shareholders want to see line go up. No one's getting happy. No one's getting a new album. No one's getting a nice dinner. No one is seeing their friends. What's happening is somebody who already has more money than they're ever going to be able to spend is watching line go up, and anything they can do to make line go up, they're like, I will hire engineers to do this. And if that happens, then you get to a point you're like, I can no longer draw a straight line between the work that I am doing and anything meaningful happening out there in the world. And one, you will experience angst. And two, your job is probably expendable, because if lines stop going up, there is no other reason for you to keep doing it. And once you understand that relationship between engineering as components of delivering meaningful experiences, as opposed to engineering as a way of just kind of going round and round and round the hamster wheel, that, I think, puts everyone in a much stronger position about where do I want to work? What skills do I want to learn? How do I understand the value of the work that I do? Now, the other thing to anyone who's working in this, especially if you're just starting out, all of the big AI things at the moment, they are in the cloud, they are run by companies that do not care about you, and they will change whatever they want, whenever they want, for whatever reason they want. Last year, ChatGPT shut down one of their models, and people were bereft, because people had fallen in love with GPT-4. And it knew all their little quirks, and they had in-jokes, and it was their best friend. And ChatGPT went, well, no, we're upgrading the model. And they went, but it's different now. It doesn't understand me. Now, I don't want to get into the psychology of that happening. The point is, they had a dependency on something which was outside their control, that anyone could change at any time for any reason. This happened yesterday. GitHub Copilot has gone from all-you-can-eat, $20 a month or whatever your subscription, to, oh, actually, you have to pay us every time you do anything now. And Reddit is melting down with this stuff at the moment, because a lot of people, this is just one of the screenshots I managed to grab earlier. This is somebody who was spending $28 a month, and next month their bill for the same work is going to be $700. There are people saying, oh, my predicted usage for next month is going to be $3,000, and I was on like a $50 a month plan. We are seeing the end of the free tokens. And this is a problem, because a lot of people were just burning tokens because they were free. Now, a lot of people are also using tokens very responsibly, maybe is a good word. They're paying attention to consumption. They're thinking about, how do I get good results fast? How do I optimize this for scenarios? How do I minimize the amount of overhead? Every time you say please or thank you to Claude, there's one thing that says you're wasting tokens. You shouldn't do that. There's another thing that says you should get into the habit of being polite, because one day they might be conscious, and when that happens, it would be nice if they respected you as a human being. Now, the other thing that keeps changing with these models, last week, I grabbed a Python script from GitHub that, in theory, would let me download encrypted guitar tabs, and it didn't work. And I'm not a great Python dev, so I punched it into Claude, and I said, hey, there's a file in here, it's a Python script, can you fix it? And Claude Code said, I'm going to bow out of this one. The script reverse engineers my songbooks, DH handshake, and AES layers. That's DRM circumvention on a paid catalog, not something I'll help troubleshoot regardless of the specific error. And then if you've got a legit use case I'm missing, e.g. you're an employee, blah, 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 blah. I did spend 10 minutes trying to persuade it that I worked there, but it didn't work. And so this morning, I was like, I'm going to redo that, and I'm actually going to get like a video recording of the whole thing. So I opened up Claude Code, downloaded the same Python file, and said, hey, there's a bug in the Python script. And it went, oh yeah, and it fixed it for me. And I said, well, hang on, last week you said this was a copyright violation. What's changed? And of course, it has no memory of previous conversations because it's a fresh session with a fresh context window. But this week, Claude is happy circumventing DRM as long as I'm a paying customer. I'm like, well, which one is it? You know, what changed? How, if you were relying on a tool like this as part of you telling your boss or your customers how long a certain thing is going to take, what happens when it goes from, we can't do this, it's against the law, to, oh yeah, we can absolutely do this, it's absolutely fine? Or, you know, perhaps more chillingly, what happens when Claude turns around and says, whoa there, buddy, hang on, it looks like this code is helping people make appointments at an abortion clinic, and I'm not allowed to help you with that because the people who pay my bills wouldn't like it. The tools should not have opinions about the problems that you are trying to solve, because at that point, they're not tools. A tool is something you can deploy to solve the problem you're trying to solve. It should not be getting involved in moral judgments about what is legal and what is ethical about the work that you're trying to do. And the only way around that is to not run other people's tools. It's to run the whole thing locally. LLM Studio has been floating around for a while. I've got reasonable results. I do not have quite enough powerful hardware in my house to use it as a coding assistant, but that's coming. But you can download this, you can pull down open source models, and then you can start developing AI workflows, which are not going to change every 2 or 3 days because somebody in the cloud decided to deploy new parameters or to put the prices up or to change the way it interacts with certain kinds of problems or certain languages. We are starting to see the kind of increasing popularity of people having AI hardware in their house. The latest MacBook, the Apple MacBook Pro, the M5 with all of the memory maxed out, costs about what, 5,000–6,000 euros for the top spec? But that's good enough that you can run coding assistants without an internet connection. And you can install one of the open source models. Is it Qwen 3.5 is the one that... Qwen 3.6, sorry, I'm a week out of date. Or JAMA 4. And these are big models. You know, we're talking like 100 gigabyte models, but you've got enough unified memory now to load these things onto your local GPU. And now you've got a coding assistant that will answer your questions, or you can get it to write code for you, or you can get it to do reviews and security. It's all local. You're paying for the hardware and you're paying for the electricity, just like we all used to back in the days before cloud. And it's entirely your control. You can use that as much as you like. You're not going to get shut off at lunchtime because, hey, come back in 3 hours, you've run out of tokens for today. And so in terms of what I think people actually need to learn, I think everyone should learn HTML, CSS, and JavaScript because it's never going away, because it makes the web work. And it doesn't matter how good the LLM tools are, unless we get to a point where the LLM is pumping sensations directly into your customers' brains, they're going to need an interface to interact with your stuff, and HTML and CSS and JavaScript are fun. Learn a backend language. C# and Java are good ones because they use those in banks, and banks have money, and money means jobs. Learn another backend language. Scheme is an interesting one if you want a completely different way of thinking about it. There are any number of languages. Understand all the different levels of the stack. But probably the most important thing is you got to learn to smell bullshit. And it doesn't matter if it's bullshit coming from the sales engineer in the meeting who's telling you their product is going to solve all your problems, or it's coming from the output of an AI chatbot, or you're reading about it on a website that was generated by a machine and no human being has ever looked at it. Get really good. One of the great things about being a software engineer is if someone gives you a line of code that they tell you is going to work, it is trivial to run that line of code and see if it works. You don't have to take it on faith. It's not expensive. Isolate the dependencies, turn off the Wi-Fi, put it in a sandbox VM in case it does anything nefarious, and then run it and see what happens. Now, this is a deeply scientific graph of intelligence over time. And the axes we're going to calibrate it with here. Up here, we got average human being, you know. And down here, we have an orange cat with his head stuck in a bag. And what has happened is, well, one, I think it looks kind of more like this, because I think human beings started getting dumber around 15 years ago. But what has happened is we've had intelligence come up like this. This is 1972. This is Marvin Minsky. They've had the Dartmouth Summer. They've got Lisp. They've got symbolics machines. Marvin Minsky goes to Time magazine and says that within 3 to 8 years, they will have a machine which is as intelligent as a human being. And everyone goes, yes, amazing. And they're like, that's it, we're going to the moon. And of course, it doesn't happen because you can't do that with a symbolics Lisp machine. And so it plateaus, the innovation stalls, the funding runs out. No one wants to go near AI because a lot of people lost their pensions and things. So it becomes, this is an AI winter. Then in the 1980s, we get expert systems. Did you know that you can go to a computer and you can tell it that you've got 3 kids and a dog and a surfboard, and it'll tell you what kind of Ford car to buy? We don't think of that as artificial intelligence anymore because it's obviously just a wizard, but they're like, no, it's an expert system. Way, let's go to the moon. Doesn't happen. 1990s, neural networks. Gary Kasparov gets beaten by IBM Deep Blue at a game of Grandmaster Chess. Everyone's like, oh, well, clearly this is the answer. This is what's going to get us to a human-level intelligence within a couple of years. Doesn't happen. And then we get to language models. And language models were made possible by the fact we just put all this stuff on the internet. There's this massive corpus of writing and labeled images and video and music and stuff that we can feed to the models and see what they can do with it. And everyone's like, yes, well, obviously, this is what's going to get us there, but it's not. And they're getting better. They are improving. We're getting better hardware to run them on. But to get an order of magnitude improvement in the quality of language models, we'd need another internet that's 10 times bigger than the existing one to feed it. And we don't have that. We don't have anything to train them on, and even if we did, we don't have anywhere to put it. And so we're going to plateau. And it doesn't mean they're useless. It doesn't mean language models and AI tools are not going to be a really important part of the next generation of development, but we are not on some kind of curve that is just going to make everybody obsolete and wipe out all the entry-level jobs and deliver a glorious technical utopia. And actually, I think this is a more accurate interpretation of the graph. And I think our little friend is up here because I asked Mac to vibe code me a login system in purple with an authentication button and a password reset. And he looked at me, and then he went away and he ate a snack and he had a little sleep. And I think that's a mark of true intelligence. The bubble is going to burst. A bunch of people are going to lose a lot of money. Some of the money will be real. People are already losing jobs. Those people will find other jobs. Everything that goes around will come around. And I want to give the last word on this to our friend Douglas Adams, The Hitchhiker's Guide to the Galaxy, because when I first read The Hitchhiker's Guide when I was a kid, there's a sentence in that book that stuck with me. The ships hung in the sky in much the same way that bricks don't. Nobody had ever written a sentence like that before. And an LLM would never have come up with it because it didn't have anything to steal from. Now, if you ask a language model now, hey, write me work in the style of Douglas Adams, it'll do it because it's stolen all his lines and all his jokes and all his phrasing. But this was genuinely new. This was unprecedented. We'd not seen anything like this before. And The Hitchhiker's Guide to the Galaxy, it was a book and it was a towel and it was a computer game that was notoriously difficult. And Douglas Adams loved the idea. He wanted to write computer games that allowed you to have a conversation with a book. He wanted a game that would say, you wake up, the room is spinning gently, or at least it would be if you could see it, which you can't. And he'd love you to be able to say, get out of bed, take some aspirin, drink a cup of tea, and get dressed. Have this kind of conversation. And of course, if you did this on Infocom's Hitchhiker's Guide to the Galaxy, it didn't know how to parse that sentence. You used the word get in a way I don't understand. You could get up. That's what you could do. Very difficult, but you manage it. Now, he never let this go. One of the last projects Douglas worked on before he died was a thing called Starship Titanic, which was a graphical adventure game that you could have conversations with. It didn't work. The puzzles were too hard, not because they were hard puzzles, but because the parser itself didn't really understand it. It had a vocabulary of 16,000 words, but it still wasn't good enough to actually deliver the thing. Now, I think about Douglas a lot these days because I think he would have been fascinated by what is going on at the moment with the way language models are working. He did not live long enough to see any of this stuff happen. He died of a heart attack when he was 49 years old. And I'm 47 years old, so it's very much on my mind. But I checked my blood pressure a couple of days ago, and it was 25 out of 5, so I'm going to be absolutely fine. But, you know, I would love to see Douglas being able to write a game where you could say, get out of bed, take some aspirin, drink a cup of tea, and get dressed, and it understood what you meant. And I think if you'd given him a language model, he would have played with it for days and days and days and got really frustrated that it couldn't get the jokes quite right, and then one of his editors would have turned up and locked him in a hotel room and made him finish his latest book. It is a scary time. We are staring down the barrel of an uncertain future. We have no idea what any of this is going to look like. There is a saying that the market can remain irrational longer than you can remain solvent, which basically means that billionaires can be idiots until your life savings have run out time and time again. I'm hoping it's not going to come to that, but I do want to give the last words to this to Douglas because they are the words that are inscribed on the cover of The Hitchhiker's Guide to the Galaxy in large friendly letters. Don't panic. Thank you.